Hello everyone, my name is Kasha Alvin Sali. I'm a group member of Group 9. Our project title is Generative Attention-Based Mechanism for Fake Currency Node Detection. Our project name is Kasha Intel AI Fake Currency Detector. I have my colleague Kaboge Salim that will take you through the rest of the part. So yeah, on the problem statement, traditional methods are proved to fail because they are slow and error prone. So this has made us come up with an automated and advanced solution that is AI-based in nature to cut down the sophisticated fake currencies. And then the project objectives, you could see them, they'll come up with an AI attention-based mechanism to classify real and face, and then also improve model detection accuracy. The solution overview, we use the GATT model, using feature extractors, ORB, and then also the diagonal recognition, and then we apply the GATT to focus on critical security features on the currency note. The innovative aspect is the ORB for feature extraction, diagonal recognition for graph construction, and then applying the GATT classifier in classification. The flowchart of the approach is easy, as you could see, input an image, ORB, feature extraction, diagonal recognition, graph construction, then the GATT classifies real or fake notes. Then the dataset we used, it was a public dataset. Those are the images, 500 and also the 2000 denomination. That distribution shows the number of images in each folder. Then the models and techniques, we deployed quite a number of models. You could see them on the screen, the VIT and all of them. The reasons for choosing the models were because of accuracy and also feature extraction. Then also overcoming data scarcity where to deploy, develop again. Then system architecture is simple as that. We had a UI where a user can upload the image, and the API sends it to the backend for pre-processing. Then the GATT applies its attention mechanisms, and then the results are uploaded back to the user. The implementation details, those are the ones like Python and all of them. Then the results evaluations, as you could see them, but we chose the GATT as an overall.
Good evening. Good evening. My name is Kaboge Salim, and I'm here to add on from what my groupmate said. Speaking from the relevancy and the impact of our project, the relevance, of course, we know that our system helps banks and financial institutions quickly identify fake notes and reduce fraud. And of course, on the part of target users and beneficiaries, we have banks and financial institutions, public, businesses, government, agencies. Then on the SDGs, of course, SDGs are applicable to our system. We are having SDG number 8, 9, and 17. As you can see them here, you can come and review them at any time. Then the intellectual property and innovation, I'll begin by talking about the innovation of our system. It's because we use the graph attention network, which are the GATS for fake currency detection with integration with ORB. ORB is for feature extraction, then the only translation is for drawing the graphs. And then the potential intellectual assets we have the patentable aspects, which include the model itself, the unique preprocessing pipeline, and the real-time Flask API, which we develop using Flask. And then on the copyrightable aspects, we have the Flask API code, the model itself, the implementation of it, the training scripts, and the documentation. Then on the monetization and the scaling, I will talk about the business-to-business SaaS model of how we can get money and income from our project. Of course, this is through subscription. Of course, banks and financial institutions which be using our project, we have to subscribe to our system. And then another thing, we have API integration. For example, any project, any business that requires to use our services can do that through our APIs, which will be online, and the fintech companies can come and use that, for example, ATM manufacturers. Then the potential size market, for example, over 400 commercial banks in sub-Saharan Africa could benefit from this automated counterfeit detection. And then we're part of SWOT analysis. I will talk about the strength, weakness, opportunities, and the threats. The strength, we are having, of course, the model itself. It's an overgraph-based approach for fake currency detection. Then real-time detection reduces financial fraud. Then the weaknesses, we are having requires high quality training data and also adoption to barriers because of the adversarial training. And then opportunities, we are having high demand from banks, like fintech companies, I'd said, and then also competition from existing AI-based detectors or threats. Then the system demonstration, this is the UI, you can see. Then team contribution, everything is here. The lessons learned, of course, we're having limited resources in terms of processing power. We're also having a limited data set, which was entirely sidelined to the Indian rupees. And then the feature work, focuses on multi-currency support. Of course, we want to use USDs, euros, and Great Britain pounds. And then we also have mobile app integration and also AGI for real-time detection. And this is also part of what I was saying in the previous slide. Okay, I will thank you.